Jake came from with his infinite size, infinite area.
I
No,
think.
I don't mean that. I mean, like, I don't know where you got the idea.
I think Jake has ESP. I'm getting a little freaked out right now.
What? You're freaked out?
I'm a tiny tidbit freaked out because I think Jake has ESP.
Oh my goodness. Jake?
Polygons with infinitely many sides is exactly what we're talking about
Yeah, I
today.
saw the lesson title.
Oh, okay. Well, then that doesn't...
That's all what
So you saw this before you came into class? Or, like, just you started...
Oh.
Ah.
Okay.
Man, you should have said you didn't see this, and you just, like, the thought came to you on your own, and then I just would have been spooked. So, if you grab a shapes template, we're going to start with a pentagon, which, actually, there was a pentagram on Mr. Hall's
Oh, yeah, I
Christmas board.
I don't. Wait, did I do? No.
I don't know.
What's the significance?
I helped with that, though.
What is the significance of a pentagram? Because it's not, like, everyone is always like, oh, it's evil, blah, blah, blah. But that's not necessarily what it is. Hey, Jake, you ended up with COVID or whatever, and I've had this one to give you for a very long time.
You mean the star?
This was yours. I was going to make you guys look it over and then turn it back in, but then you weren't here and whatever else. So that's all mastered. It's all good.
Shape is called a pentagram.
Well,
It's not called a star.
what's the distinction between a pentagram and just a star, just any old star?
Well, I think a pentagram is regular.
So a pentagram has some special characteristics.
Yeah. But because the regular pentagon was the same kind of isosceles triangle.
Ooh, so isosceles triangle. All right, so let's go ahead and draw this pentagon.
Yeah.
Sorry, pentagon on your paper. Let's figure out the area if its radius is 1. Remember we said the radius is going from the center out to the vertex, as opposed to, what was that fancy A word that we were kind of using altitude, but that wasn't the fancy word. It was the thing that if it went from the center and dropped down to perpendicular with the edge. Do you remember what we know? That's what we called it, but that wasn't... Start with an AP.
Aperture.
No, shush.
The Apothem.
Yeah, that's
Right, so the Apothem, sort of like Gotham, I guess, sounds the same. The Apothem would be from the center out to here. So like the height of the triangle, essentially. But it's easier, well, arguably, it's easier if we use the radius, because then we create, like you guys already said, isosceles triangles. So go ahead and figure out what the area of this is. We essentially, I think, have 5 isosceles triangles.
What's 360 divided by 5?
That would be,
It's 36 times 2. It's 72. Thank you so much.
I knew that.
And then,
Wait, but we didn't even need the 72, because that's just 36. What is that? Yeah. And then, wait, are you getting both area and perimeter?
sure, yeah.
Oh, that's gonna be hard.
Perimeter's going to be harder.
Yeah, because they don't have a calculator.
And this isn't a hexagon, right? It'd be nice and peachy if it's a hexagon.
Oh yeah, I like peaches.
Millions of peaches.
There it is. Okay, let's dig out a calculator.
Not that kind of peach.
Okay.
So you said this is 72.
But we don't even really need that.
So if we cut that in half, so the 36 is kind of what we need. So you could have really just divided by 10, right? That kind of would have been like a quicker way since we don't want to cut this in half. So 36 is in there,
And then
which means my base angle down here
54.
is 54.
Yeah, and then you do like cosine.
Ooh, sine or cosine, right? Because we got to use the
Oh,
hypotenuse.
Well, no, if you use
It's
cosine,
definitely not 1.
No, I mean it's nice at the length.
So we are calculating the apothem, right? This red line that I drew, we're saying that's called the apothem.
Oh, we're trying to calculate that.
Well,
was
we
gonna
need
do
both.
the perimeter first.
We need both.
That's
So
what
if you're
I was
thinking
like,
perimeter first, you're
you
calculating
can
the
just
edge.
do 10 times the cosine of 54.
Okay, so when you calculate one of the edges, I guess give it to me.
Well, one of the edges is 2 times the cosine of 54. So you
Where's
can-
your calculator? You haven't lost it, have you?
It's in my backpack. I just don't know.
Man, that's so far away.
Yeah. I think it's within arm's distance.
Yeah, well, it's on the board.
Look at how much faster that
Oh,
was.
dang.
Delivery with a smile.
But why can't we just leave it in like cosine notation?
I mean, so here we're going to want to work in decimal notation to be able to compare numbers with each other, but you could also leave it in like radical form if that makes sense, as long as we're going to be able to compare the numbers with each other. But I don't think leaving it in cosine notation is something that we ever really do, because that's not a very clean way to talk about numbers.
But it's the most accurate way.
Not at all.
No? What do you mean no?
So what's the cosine of 30?
I think it's 2 or 1/2.
If we don't know,
It's either
then it's
2 or
not
1/2.
very useful.
Well, but it's
Okay, how's the
accurate.
cosine of 30 compared to the sine of 30?
It's 1 over the other one.
I think you're using opposite dangerously incorrectly. Remember, opposite is like positive versus negative.
It's the reciprocal.
Ooh, the reciprocal.
Wait, is that true? Yeah, is that true for all shapes, or is that just a 36? I don't know.
This is why I'm saying we shouldn't leave it in cosine or anything form. We should put it into decimal form.
I like cosines.
So how did you find the apothem, Akshay? How did you find the apothem?
I did cosine 36 equals x over 1, so then I just did cosine of 36 and my x equals 8.
So you did x over 1 because that was the adjacent and the hypotenuse here. Oh, that's nice, because then really the apothem is cosine of 36. But if I tell you the apothem is cosine of 36, what the heck does that mean?
It means it's what you get when you divide.
Okay, so we're going to calculate the area here, and we're going to say the area is 1/2, whatever this edge length is, times the cosine of 36. I think we're going to end up using decimal form. So we're going to go ahead and say that hundredths place accuracy is good enough for this exercise.
But it's actually the cosine of 54 times the cosine of 36 divided by 2. Wait, no, not divided by 2. Wait, is that a cool number? Or is
So
that
if we're looking to find our edge length, I could use the 54. Connor's got a good point here. If I'm like a big fan of cosine, we can still use cosine in finding this apothem, or not the apothem, the edge length, sorry, but this is the adjacent. Right? That's our adjacent, so it's half of one of the edges.
I think I got it.
I don't want to use x again. I really, up here, we probably could have used a, since we called it the apothem.
So we'll call this one B.
Yeah, I'm actually going to come up here and change this to a. Certain letters you can just write over a bit heavier and make it disappear, right?
Yeah.
So now I'm going to go ahead and use x here. And say, just label that x. So cosine of 54, I guess, times 10 will be our perimeter.
Yeah.
That's not a very nice way to say it.
It's 6.61.
That's a nicer way to say it. Well, I don't know. I don't know if that's right, but that's a nicer way to say it. Hey, make sure that calculator's in degrees, since it's not your normal calculator.
Might be, yeah, I might have just messed everything up,
Yeah, I'm on.
Yeah, but Connor's not using their calculator because
I
they didn't want to reach into their backpack.
Because I don't know. You know what? I feel like it'd be less work at this point for me to just get out my own calculator.
It wouldn't be, but
What a
Well,
concise
because I don't
realization.
know how to
you go to mode.
degrees. It's not a graphing calculator.
No, it's not.
Yeah, So
Well,
how
'cause
does that
They were
calculator-
complaining about their calculator being in their backpack, so I just tossed the TI-30 at them. But then if it's not our calculator, we got to double check some things. And quite frankly, the TI-80 series shows so much more on the screens. It's a lot more convenient to be able to see all those numbers. So what do we get for cosine of 36, Akshay? 0.81. So like less than 1. Oh, well, that makes sense because the hypotenuse is 1.
Yeah.
So we're saying A is 0.81.
Okay.
I want to test
It was a gradient.
Because if you guys get the same answer as me, then my finger works.
Wait, did you finish
No,
yours?
it doesn't. Yeah.
Okay.
So you-
Don't worry, you'll have plenty of chances to check it today.
It probably doesn't work.
Then I'm thinking X will be smaller.
Let's go. It does work.
Don't worry, you'll have plenty of chances to check if it works. What is X? Cosine of 54? Like,
Okay.
what is that?
Huh? I didn't do that.
I'm very curious about what Jake's equation.
Did you get X, Connor? We can circle back to Jake's equation.
It's the cosine of 54.
Yes, but what is the cosine of 54?
Well, like X isn't all that useful. I guess it's 0.5877785252.
So wait,
0.59,
0.59,
just 2.59.
0.5.
No, wait, I would like to argue that X isn't all that useful. How are you going to find the perimeter without X?
Well, okay, but you can just do 10 times the cosine of 54, and like you can just use cosine of 54 because it's more accurate, and then you're not doing rounding, and then just for your end result, you can put the.
I 100% agree with that. Like, I am on your team with that statement. But saying cosine of 54 is not that useful, or the decimal, whatever you said, like, depends how you're wanting to solve it. But I agree, if you're solving it your way of just multiplying by 10, then yeah, we'll save a decimal place of accuracy. Because if I just multiply this by 10, I'm going to get 5.9. But if I keep the other decimal places, I'm going to get 5.85, 88, something like that.
Which is close, but slightly different.
Close only counts in horseshoes and hand grenades.
Wait, close counts in horseshoes?
Yeah, you get a point if you're one horseshoe within distance of the pin.
Oh, yeah.
Yeah, that's how that's where that saying came from.
I've never heard that.
And if you get a hand grenade close to your target,
Yeah.
it's probably going to do what you want it to do.
Unless the person's like Captain America crazy and just picks up the grenade and tosses it back.
So do we have our area here yet?
Yeah, I got it. So did Jake. Jake got the same answer.
I think I got. What area did you guys?
What did you get, Connor?
What did? No, 2.85 units squared.
I got 2.38.
Yeah, same. I got 3.38.
2 against 3. I don't know.
One of them's using a weird shaky Jake formula. So.
2.38 is correct.
Boo! 4! No, 3 against 4. 75% of the group. Yeah.
3 against 4? Connor, apparently you are worth 4 now.
Dude.
I feel so smart.
Connor is they, themselves, another one, and another one. There are 4. Okay, so let's...
Oh, what's
Oh
that?
yeah, we got a lot of fun to do. So let's go ahead and make a little
Wait,
table
what
to
did you
organize.
guys get?
Let's...
2.38.
Silly.
Hey, let's make a little table.
But I
How
disagree.
long should this table be?
Connor disagrees,
Big.
so we're wrong.
Like,
Yeah.
This should be a big table.
Wait,
how
how?
many are there? 16?
Can we go back to the question that I don't understand?
We can in a moment after you make this table.
Oh.
Letters, or are there
Wait,
12?
wait, wait.
I would leave yourself at least like 10 spots.
What are we doing?
C, D, E, F,
We're making a table. I'm just asking you to.
L, 12.
We're gonna do.
Wait, did you guys get 2.38?
Yes.
Oh, now I understand what I did, Josh. I'm very sorry.
Sides. Area. And perimeter.
Oh, no.
Now hold up. We're gonna calculate for 3 and for 4 as well. So you might start wanting to split up. But for 5 sides, we just said 2.38.
Oh, we're doing things with a radius of 1.
Yeah, all of them are gonna have the radius of 1. And our perimeter we found to be. Connor, I know you have that.
5.88. I may have multiplied the area by 6 instead of 5. Okay?
Because the other day we were working a lot with hexagons, right?
Maybe. Or maybe I just forgot.
Don't go fast. I'm still working on making my table look nice.
Well, I'm not working on making my table look nice, but I am still working on making my table. Are we going up to what
Now you can make a vertical table if you want, but my advice would be make a horizontal
I just
table.
made you a
Oh. We're not going by the
What?
I just
Oh.
put 1, 2, 3, 4, 5, but we're not going by 1, 2, 3, 4, 5.
Well, there is no one-sided shape
Well,
or two-sided shape.
well, yeah, there is. Online.
Well, polygon. I guess we should specifically say.
Fine, I guess.
So, if we still had it in our notes, we might still have the area and perimeter of a regular hexagon with a radius of 1, but I'm not sure if we did that, because it might have been an apothem of 1 when we did that.
Yeah, I think you might be right there.
I think you're right.
Yeah, check your drawings.
Yeah.
I don't know that we have this one done.
No, I feel like a hexagon wouldn't be that hard, though. You know?
Well, so would you like to claim dibs on hexagon?
I want hexagon and triangle.
So you want 3 sides and 6 sides. Alright, so Connor's going to go ahead and solve this one and this one.
I'll do 4.
Akshay would like 4, and do you want to pick another one of the options that are up here? We did pentagon, we're doing hexagon,
No.
octagon. So we skipped 7.
Wait, I feel like I made a bad decision here.
So octagon,
I'll do 8.
nonagon. Wait, we do have a 9-gon, but we don't have a 7-gon up here. So
Oh,
they do 9-gon. Jake, would you like to call some dibs?
I'll do 8.
I'll do all the like 30, 60, 90, 180.
Wow.
What?
Okay.
You want
Oh,
to do the
these?
giant one?
You're doing okay. Jake wants to do the giant ones.
Cool.
I think
Okay.
really he just wants to test out his formula with some really big shapes.
Okay, so it's
All right. So Akshay is going to do 4 and how many sides? You want the octagon?
Yeah.
And Jake is going to flex on us and do the 30, 60,
Wait,
and
so what are we
90 sided
doing again? I
guns.
forget. What are we trying
Area
to
and perimeter.
Okay. And the what's the one thingy? What has
The radius from the center point to the vertex. So I'm going to give you guys a few minutes because this might take a moment. Now realize that we're working in different units here, but we're going to do a comparison between the numbers. So this is why we're building this table, is so that we can compare the numbers with each other.
Are we not doing all of them, or are we only doing the ones that are on that table?
I mean, we could do more than this, but I have a feeling by the time we do that, we'll end up... Well, let's add 180 on the end just to be
We're
crazy.
skipping 2 numbers. But yeah, 180 and 50.
Okay.
Like,
I'm thinking by the time we get out here, we'll be able to kind of derive what we're supposed to see.
fair point, fair point. If there is something.
So Jake, you're claiming these. Actually, I don't think you did the 10-gon. Because I'll do the ones that are left.
Okay.
So I need to do the 9-gon and the 10-gon, I guess. Do I have to draw out the actual nonagon?
Well, I like
Yeah, but do we have to?
no.
Right, we wouldn't have. The main thing we have is that isosceles triangle. Well, the main thing that we care about more so.
So the square root of 1 is 2.
The square root of
Whoa,
1
wait, what?
is not
Is
2.
this
The square root of 1 is 2.
No, the square root of 1 plus the square.
Well, what's the square root of 1? 1.
Oh yeah.
The square root of 1
Okay.
is 2.
2 times 2 is 4. Okay, that's the area. 2 times 4 is 8. That's the perimeter. Great, I did that. Yay.
0.25. Multiply that by 6. 1.5 radical.
APO them. Like literally APO them.
This is exactly how it sounds.
Yup.
Wait a second.
What?
Alright, I'm gonna do this.
I think I may have figured out something interesting.
Keep it to yourself for a moment. If you think you have a, what would we call it if it's something that we think is true, but we, if
Conjecture.
you think you have a conjecture, test it by doing it with another shape.
What?
We didn't put it up there. I mean, we can if we want to. I'm doing the 9-gon and the 10-gon because actually 9-gon's kind of easy, not to use the bad word.
Oh.
How many right triangles would you have in a 9-gon? 18, which works nicely with 360. So, haha. Joke's on you guys. You left me with the easy one.
Well, I only have to do 2, and I feel like that 3 was a bad decision.
The 3, you mean a triangle?
Equilateral triangle is easy, but it's from the center of the triangle.
Yeah.
And that's why I feel like it's gonna be harder.
Okay. I mean, you chose it. Are you trying to back out?
I just think it was important.
You're gonna be a great mom someday.
Hey.
Shush! I just got like scared at that shush. And the emphasis at the end. Shush! Ah! What'd you do today, Micah? I got yelled at by some 14-year-olds.
Wait, oh, that's cool. Oh, that's really cool.
So 45 divided by 2. No,
Dude, that's so cool.
I don't want to do that. I think that that's
So all of these have a radius of 1, you said?
That's just a cool thing with equilateral. Yeah, that's what we're doing. Hey,
Cool. Just making sure.
I just figured out a cool thing with equilateral triangles.
What is that? That all the angles are equal? Sorry, I'm just being all the sides are equal? What's the cool thing?
No, it's that, like, you know how a hexagon has 30, 60, 90 isosceles triangles?
Yeah.
Regular triangles have it, like, rotated. They have a 60, 30, 90 triangle.
Ah, well, isn't a 60-30 still a 30-60?
Well, yeah, it's rotated.
And actually, this one makes a cool shape. When you do the equilateral triangle, looks like some like Triforce sort of thingy.
Area equals.
Always double check your mode.
Wait a second.
And actually, if you like a bit more accuracy, just hang on to more decimals until you get to the end.
I just use the answer thing.
Wait.
Oh yeah, well that works too.
Wait. That's interesting. Why? Why is that? Oh, that's the way it is because I didn't do that part right. That makes sense.
Crap, wait, not one right triangle, one of the isosceles triangles.
Exactly double.
Good.
Huh? No. No. This hurts my brain. Either I did some math wrong, or this hurts my brain. But I'm gonna go put my answers up on the board so that we
I'll let you know if there's anything wrong.
have some
Times
there.
what? How many times 8?
perimeter? That's exactly 4 times that. Okay.
Okay, so that, whoa. So that's the area of that. Multiply that.
Is that good, Mr. Hudson?
Is that 2.12?
Yeah.
It almost looks like 2 divided by 2. For the triangle, that is not correct, actually.
Did I get right for the hexagon? Wait, I need
You did not. So we need to go back. Your perimeter's right for your hexagon.
That means what I've been doing is wrong.
Did we write out our work?
For 8, 6.12 and 2.8.
Yeah, but you flipped. Your table's just flipped compared to mine. I have area, and well, so do you. So you've actually written these in the wrong places. Yeah, so your area
I did, didn't I?
is smaller than your perimeter,
Okay.
but they're different units.
Are they right?
Yeah, now so now you can add them to the board if you want.
I know, that's what I'm going to do.
Wait, that should be 0.5, right?
So, Connor, I wasn't drawing this because I expected you to goof up or anything, but I like how this shape looks, and I was just going to bring up that this is fun.
Wait,
So it's this is 1,
I just realized
and
what I
our
did with the
Apothem, this
and
is
I
30.
realized what I did with the triangle too.
Wait,
I realized both of my mistakes. Can you put it back?
So sad.
yeah?
Because I realized that I actually had the right answer earlier for the hexagon.
Make it in your best handwriting as possible.
No,
Oh.
Okay, I'm gonna have to redo these.
I think that's it. 'Cause
You
I think
need some assistance, Jake?
No, I'm good.
I doubled it.
We're good. I just
So
messed-
wait,
I just messed something up with my time.
that hexagon area is not correct.
Is it?
This is not correct.
I don't like this.
This is why we're practicing this, because exactly what we've been talking about the past couple class days of we get too comfortable and act like we're too good at these things. This is why we're practicing together.
I don't like this.
That is not correct for
Wow.
your square.
Really?
Either of them.
We're all getting it wrong. I feel like there might be something going on.
I did the harder one right, but not the easier one.
Is this the pattern you were talking about?
Is this the what?
You're like, we'll discover a pattern. Is the problem we're bad? Is the pattern we don't solve it?
So, yeah, that's in the right place now. 6.12. This is correct. This 6 is correct. But I think that was Connor's.
Oh, I know.
Hey, let's review.
I know.
So
what
for
I did
my
wrong.
nonagon, right? For my nonagon, I did not draw the whole nonagon. Hey guys, I have advice for you. And it doesn't matter if this is to scale. So I just drew the isosceles triangle that would be created by the nonagon. Then I took 360 and divided by 18, because there will be 18 center angles in a 9gon. So I get 20 and 70 for my degrees. Then I can cosine to get both the apothem and half of the base or half of the edge. That tells me that one isosceles triangle would have the area of this, because if I multiply my x by my a, right, this is half of the base. And this is the height. So that's the area of the isosceles triangle. So then I only have to multiply by 9, because when I take my half of the edge times the apothem, that is one of the isosceles triangles. Right? So I'm solving the area of the whole thing, even though I'm only using half the base, because that's what we want to use, because it's a triangle. Go back and check your work. You want to throw them at me before we write them down?
For the perimeter of the triangle, I got 4.5.
No.
How is that not right? I don't get this.
You want to tell me your setup?
I have 0.5 radical 2 as my x.
Hold on, you got to take it way further back than that if I'm going to help you out.
Okay, I got an equilateral triangle.
Equilateral?
Yeah.
Well, there's your problem. Are we sure about that?
What do you mean? Aren't we doing regular shapes?
Yeah. So, if I am pulling from in here, this isosceles triangle, which totally doesn't look right when I draw it using my shapes template.
Well, yeah, but I mean, to start, I have an equilateral.
Oh, okay. So to start, so we have some like z, right, which is really 2 of our x's, but sure, that's equilateral. Yeah, it's regular.
Radius of 1.
So we've got 1 and 1.
And then, I'm gonna draw a mini. Wait, why did I draw the mini
So
triangle?
this would be,
That doesn't matter. We only need half that angle,
okay, well, what's half that angle?
which is 60. Because 360 divided by 6 is 60.
Oh, so this, which looks to be my small angle with how I've drawn it here, this is actually 60, which means this is actually 30,
Yeah. Which means the apothem is 0.5.
which means the apothem would be, how'd you find it?
So it's 30, 60, 90 triangle.
Well, sure, but if we want to double check the trig,
Cosine
wouldn't it be
60.
cosine of 60, right? Because then we said that would be multiplied by 1. So let's double check cosine of 60. I get 0.5.
Yeah.
Okay.
So,
So then our x, which is like half of our base, can be cosine of the other angle.
cosine of 30.
Yeah, what's cosine of 30?
It's radical. Oh my goodness, now I get what I was doing wrong.
Oh my goodness. Now I
forgot
get.
How 30, 60, 90 triangles exist in the world.
Well, this just doesn't look right. At least I've drawn it. Like,
No.
it is right, but it doesn't look right.
No,
Because
Mr. Hudson, I've been doing radical 2 and not radical 3.
that's why I tried to get you to memorize that these are all factors of 3, or
Yeah.
multiples of 3. So wait, so this is radical 3, you said, which is like
Well, it's
1.7.
radical 3.
Oh, because it's the short. Wait, what?
Because that's the long side.
This is the long
Which
side,
is
even though it looks wrong here.
times the short side.
So 0.5 radical 3.
Okay, now I can do it.
Now you can run with it. Check.
That was right.
5. What is that? 6.6? Yes. And 2.83, 6.12. Yes.
Great.
Wait, so. Oh, okay, I never mind. I can do
I'm done.
Oh, my 7th graders were impressed by your the hexagon that we like drew the circle around, and we were looking at all the like exterior angles. They just thought it looked cool. My 7th graders who come in for math lunch.
When are we going for lunch?
8th at
Okay, I'm
18
gonna
today.
have the triangle.
You got the triangle?
I think so.
What'd you get?
For the area, I got 1.299.
Yeah, 1.30. Yeah, because we're gonna round a hundredths place to make life easy on the
Okay.
table.
So got 1.30.
Okay.
For the perimeter, I got, if we're running to the hundredths place, 5.20.
Yes.
Okay.
Can I
Jake.
finish up?
Food for thought, because you haven't thrown any numbers at me. If we think about how different would a 90 gon versus a 180 gon be when they both have the same radius, will they be substantially different or fairly close to each other?
They'll be fairly close.
Yeah, because they're going to look very
I'm
similar.
getting like almost all the same answers for all of these.
Interessante.
It gets exponentially closer together.
Interessante. Yes.
It's where you go. Wait, From here, that's like a 70-degree.
So wait, Connor, would you add my numbers for me?
What? Yeah, sure.
My 9-gon had an area of 2.89.
That's like nothing.
That's like something.
I mean, that's.
And
like
had a perimeter of 6.16.
Oh, can I?
Sure. Actually, you can write my numbers for my 10-gon up there. My 10-gon was 2.94 and 6.18. Very close to. So, like, my 9-gon and my 10-gon are very close to each other, especially their perimeters. What can't be right?
Connor, did you
You are correct. That cannot be right.
This one?
Yeah, I'm doing that right now.
So wait, for 30, 60, and 90, is it for area? I got 3.12, 3.14, 3.14.
Yes. Are you wanting to go up and write those up, or do you want to actually add to? I mean, I can. Choose the small pen because we made the boxes small. So, like, choose small thickness.
Technically, Mr. Hudson.
The screen is only so big, Sassafras.
Okay.
Sassafras is actually good tea.
I'm sad Sassafras went out of business. Or they didn't go out of business. They just like went out.
See, that's funny that you guys know Sassafras from the place. I know Sassafras from the tree at Scout Camp.
I mean, that's what I thought of.
Yeah, it's a tree that you can take the leaves off of and make tea. It's tasty.
You know, I like the bakery better.
Wait a minute.
And then I haven't done the 180 because I think I screwed it up.
60.
If we were to make a conjecture, the 60-gon and the 90-gon, like, match.
Wait, Mr. Hudson, just 1 second. Is the area of the hexagon 5.2?
Of the hexagon?
Yeah.
No. Wait, you're too big. I think you multiplied by double what you should have. You're literally double what the answer should be.
Oh, that's why I did it wrong.
Did you multiply by too many triangles?
Oh, yeah, it should be 1.5 fractal 3. I for some reason I thought 0.25 times 6 was 3. Don't question.
Is that 8.18 for the
Alright, I got it this time.
6.18 for the 10-gon.
No,
It's 6.16 for the 9-gon.
I'm gonna have to write really small here.
So what we can see is both the area and the perimeter are getting larger as we go up until, and Jake used the word exponential, because it kind of like slows down.
Yeah.
Because we're leaping
Even
exponentially.
like here, it jumps by like a half. Like this
Yeah,
is
because
70.
Because this is only a jump of 1, whereas this is a jump of 90.
Yeah.
Well, jump to 30. Well, yeah, okay, jump to 90 at the end.
No.
Jump of 20, jump of 30, jump of...
I was more talking about like the growth from one stage to the next. Like this is 0.7, and then right there, that's half that. Like a little bit
Is 90?
less than even
Wait,
half that.
what does 90 area
But
say?
it doesn't
6.28.
seem like it's a
Or,
uniform
sorry,
amount.
3.14.
'Cause,
Area
like,
is 3.14
So my
for
theorem
the
does
last
work.
3.
Let's go.
this to
And then
this to this to
60
this,
is
this is
3.1.
like half.
This is
So,
a theorem
the-
1, 2.
I think what Jake said was the 60,
Or
90, and 180 actually got the same values. He just wrote extra decimals on the
Give me
180
your
gon.
paper, please.
Wait, anyone recognize anything about what these numbers are like slowing down at?
We're getting close to pi.
Yeah,
Because
they
pi
are.
is a circle.
Because pi is
Wait,
Yeah, a
so
circle
hold
has
on.
infinite sides.
Amanda, you can drop something off, but we're in the middle of, we gotta wrap this up.
And the infinite side is chasing.
You're good, you can drop that off if you want. So wait, what you're saying is compared to a circle,
Oh, because the area of a regular.
the
The
triangle,
perimeter is 2 pi.
the triangle
would be real
kind of silly doesn't fill up the entire, it leaves a lot of extra circle, right? There's a lot of leftover space. However, a like even dodecagon, like very quickly, we start filling the space more efficiently.
Yeah.
So if we can imagine a 180 gon, the slivers of space that would be left out here that weren't filled will be tiny.
Yeah, it's getting so close to a circle that it's almost unrecognizable for the circle.
So what we're saying is this pattern
I want,
gets exponentially close to area of pi.
well, the area of pi because the radius is 1.
Okay, and the perimeter gets exponentially close to
Is that 2 pi?
2 pi.
2 pi r squared. It is 2 pi r squared because r is 1.
Well, remember, that's her area.
Oh,
Is
that's-
pi r squared. It's
Wait.
not 2 pi r squared. That
Why is
formula
the
doesn't
area
exist.
1? Oh yeah, pi r squared. Oh, pi times. Oh, so that's the area. And then what's the perimeter of the circle? What's the equation for that? It's like something.
Crust. Have I not taught you guys what crust equals?
No.
I don't know. It's like it's the circumference times pi, isn't it? So the circumference is 2.
I still don't know.
So it's 2. Oh, okay. Now I understand.
Who likes pi? Not pi, but PIE.
I mean, it's been a long
The
time.
pen.
Right, I haven't had pi in a while. Probably since the holidays.
I like good pi, but I really don't like that.
Actually, this picture is perfect for us to talk about this. If I get rid of this triangle.
Yeah. The triangle.
Because this looks like a pie, right? In a way, because the slices and whatever else.
Yeah, you should get like a slightly less sided shape though. Most pies have less.
What is the thing that most pies have at the bottom and around the edges?
Foil.
Crust.
I like
And
the-
what is the crust? Hold on. Trust me. You're going to love this.
Okay.
You're going to love this. What is the crust made from?
Tin foil. Aluminum.
I sure hope you're not eating foil. The crust, not the pan.
They feel like it's bread.
But what is, before it's bread, what is it?
Dough.
Crust is
Money. Dough.
pie dough.
Oh my god.
Oh, okay.
Crust is pie dough. The circumference is pi times diameter.
Excuse this interruption, Phoenix. Could I please have Maria
Dough is also
carry me into the office? Maria, please come to the office. Thank you.
So, crust is pi dough.
crust.
Or the other formula is pi times 2 times radius, which is probably why we're getting goofed up thinking that radius squared might be used. Remember, if we square something,
No,
we're talking
radius
about
squared is
area.
the area. Yeah, I was. Yeah.
Nice.
And this is also like.
Sides infinite. I like. So what Jake is saying, then he added a column to his table, and he said if there's infinitely many sides, right? So if n equals infinity, then the area, he said, is pi, and the perimeter.
No, pi r squared.
Well, it is pi. It's a one-sided shape.
Well, okay, so if we
One
keep
radius.
our radius as 1,
Yeah, but
Oh,
I'm fine for all radiuses because I just multiplied it by x squared.
okay, so we'll say or pi times radius squared, and this then is 2 times the pi.
It's like I want to be able to refer to this for every time we ever use a triangle or a regular shape from
Alright.
now on, so that we never use
In
regular shape.
extensions today, I'm gonna make them arcs.
Is this the table?
Polygon area theorem mark 3. No.
Hey, Jake.
The theorem is this.
You like Tony Stark?
Tony Stark.
Oh, that makes sense.
Tony Stank.
Well, it makes sense. That would make sense. I didn't actually read every single part of it.
You shouldn't be released yet. Who released you early? I know. Estes needs to check his phone if we're doing staggered release. Estes, you let 7th go too early, man.
Bye, thank you.
Hey, you guys have a great day.
I'm gonna improve it so that